Welcome to BTech Revision. In today's lesson, we're looking at resistance in diodes. By the end, we should be able to describe the types of diodes and calculate the resistances or current in diodes. What are diodes? A diode is an electric component that only allows current to flow in one direction. They are made from something called a semiconductor. Semiconductors are materials that are in between insulators and conductors. Insulators such as glass and conductors such as copper. Below we have a diagram showing the symbol of a diode. And you can see the left side is the anode, which would mean it is positive, and the right side is the cathode, which would mean it has a negative charge. We also have something called a Zener diode, and we can see the symbol is similar with a extra line at the bottom there, and a light emitting diode, which is similar to the semiconductor diode. It has two lines coming out, therefore representing light being emitted. What about current? How does it flow in a diode? The second way is a reversed bias, and this is when a voltage is applied to a diode and no or little current would flow in the opposite direction to the arrow, with the exception of a Zener diode. How can we change the direction of the current? This is where a rectifier would be used. And rectification is the process of turning alternating current, which is current that is flowing in two directions, forwards and backwards, to direct current, which is current that flows in one direction. For example, let's take our main supply in the UK, 230 volts, and it's AC. And this is reduced to 12 volts using a transformer. And then this can be converted to 12 volts DC, which from before it was AC, using a rectifier. And this is the right type of voltage in order to provide energy for a light bulb, for example. Let's take a look at how Zener diodes work. They resist the flow of current in the reverse biased, just like a normal diode. However, until they reach a certain voltage, this is known as the breakdown voltage, then the Zener diode will start to conduct. These values can range from 2.7 volts up to 150 volts. Now, let's take a look at this example. We need to find the current flowing through the silicon diode shown below. First, if we start by working out the total resistance as they are in series of the resistors. So that will give us resistance, which is equal to 5,000 plus 1,000, and that's equal to 6,000 ohms. Since this is a silicon diode, we know this will need a forward bias of 0.7 volts. Therefore, these resistors will gain the rest of the voltage, which would be 10 volts, take away 0.7 volts, which is equal to 9.3 volts. The diode is not going to be, since we have the total resistance, which is 6,000, and the total voltage, which is 9.3, we can work out the total current in the circuit. So I equals V over R, which is equal to 9.3 divided by 6,000, and that gives us a value. 9.3 divided by 6,000 is equal to 1.55 times 10 to the power of minus 3 amps. Now pause the video here and attempt this exam question. First, we can start by drawing the circuit. So if we have a cell here of 10 volts and we have a diode connected in series. So how do we know which way to draw it? If you look at the cell, the longer side is positive and the shorter side is negative. And looking at the conventional current, it's going to flow from positive to negative. And as we go down, we'll have resistors in parallel. And then finally, when the current flows through, it's going to come back up and the diode should be in the same direction, considering it is in the forward bias. You can label these and change prefix. So 1 kilo would be 1000 ohms. And for the second, that would be 2000 ohms. So the first thing we can do is work out the total resistance in the circuit. And if we know this is a parallel connection. So remembering last lesson, the total resistance, well, the inverse of them is equal to the inverse of the resistor 1 plus the inverse of resistor 2, which is 1 over 1000 plus 1 over 2000, which is equal to 3 over 2000. Therefore, doing the inverse on both sides, we can say that's 2000 divided by 3 ohms. Now we have the resistance, the voltage. If we know we have a silicon diode, which has a voltage of 0.7, therefore the total voltage available in the circuit is 10 take away 0.7, which is equal to 9.3. And now we have the total voltage available in the circuit and the total resistance, which would therefore allow us to work out the total current, which is voltage divided by resistance. So it's 9.3 divided by 2000 divided by 3. And that gives us a value of 0.01395 amps. And that's the end of the lesson. If you'd like to boost your grades, visit us at btechrevision.com. See you next lesson.